To get the motion control working easily, you need to build it up in easy steps. So first of all, we'll get the motor going, then we'll read an encoder, and then we'll put the two together. Here we have the Gertboard connected to the Raspberry Pi. We've got a power supply from 6 NiCad AA size cells. Got a switch to be able to turn it on and off. We've got the motor connection, the power connection, the red and the black here. These connections here are for the programming of the ATmega 328 on the Gertboard. That's following the guidance in the Gertboard manual. We've got some connections here so it can read the serial output of the 328. That's also covered in the Gertboard manual. And here we've got the power out for the encoder with a 150 ohm resistor in the positive supply. The return signal from the encoder, so we've got the A and the B signal go in here into buff 1 and buff 2. They go through the input circuitry, so we've got the jumpers set here for B1 and B2 in. That bumps up the signal, and it then comes up through here into PC2 and PC3. That's the inputs to the ATmega 328. On the output from the ATmega 328, we've got the motor B connection connected to PB4, and we've got the motor A connection connected to PD3. Here we're demonstrating motion control with a motor available from Maplin's MFA Como drills motor gearbox combination. That's coupled to a digital pot, an optical pot, which came from Farnell. It's made by Grey Hill. To set up the motor, we connect the motor to the Gertboard inputs there, and we also connect the power, which in this case is 6 AA batteries, via switch to the motor connections. So you can see the negative is the closest connection to us, the positive is the furthest away, and the motor connection is the two in between. So on the Gertboard, we're going to demonstrate control of the motor via the ATmega. So we're just going to drive it forwards and backwards, and to generate an input we're going to plug in a potentiometer. So we need to connect the wiper to PC3. I'll just do that now. One end of the pot goes to ground and the other end goes to 3.3 volts. Here's the motor control sketch. So holding shift, press on the arrow to upload it using the programmer, and there we'll upload it. So now the motor's ready to go. Having got the motor to work, the next stage is to get the encoder working. So we're going to make the encoder connections to the Gertboard now. First of all, we need to use two inputs, so we connect the jumpers in for B1 and B2, and the signal from B1 goes to PC2, and the signal from B2 goes to PC3, and the encoder, we've got channel A goes to the input buff 1, channel B go to the input buff 2, connect the negative or ground to a ground point, so we use this one here, and then connect the positive. We've got a 150 ohm resistor in the positive supply. See the data sheet for the encoder when you make that connection. So as we turn the encoder now, we should see the lights go on and off, and there we see them. You can see that there. The LEDs go on and off with the channel switching on the encoder. Having set up the encoder, we need to be able to read the counter on the ATmeg 328, and to do that we use Minicom, and following the guidance from the Gertboard manual figure 33, you need to link GP15 to MCTX and GP14 to MCTR. So now we're going to start up Minicom. So open a terminal session, sudo minicom AMA0, that starts up the terminal, and now we're going to load the sketch onto the ATmeg 328. So hold the shift down, press the right arrow, upload, and we see that the counter started there, and if I turn the encoder, you can see it's counting up and it's counting down again. Simple. Having set up the encoder, we're now going to load the motion control sketch 3, 4, 5, 6, 7R poly motion control DF for the Gertboard. I've got the sketch loaded here. We've already got a Minicom session running from the encoder setup. So holding down the shift key again and pressing the arrow, we're uploading using the programmer. On the left hand side we can see it's uploading. We started the motion array calculations, that's all the points being generated, and then the motion starts.